Right, so whereas last lesson we were looking at solving quadratic equations graphically and by using graphing technology, today I want to take one of the first of several algebraic looks at solving quadratic equations, this time by factoring, which is actually nothing new. We've seen this actually numerous times in the course already. So I'm hoping the basics I can go through rather quickly because we have been solving quadratic equations by factoring in both the previous units of times. So I'm hoping I can spend a bit more time on some applications or slightly more higher order questions. But in general, if you want to solve a quadratic equation by factoring, and quite often this can be done very, very quickly, the first thing you want to do is put your quadratic equation in standard form, which means make it equal 0. So put into standard form. Because if we're going to use factoring, then the whole reason that factoring can be helpful is that we want our individual factors to have to multiply to make 0. Because 0 is kind of unique in that 0 times anything is 0. It's that simplicity of it we want to take advantage of. And so if an equation doesn't already equal 0, we need to make it equal 0 if we're going to solve by factoring. Then you need to factor fully. And if we don't factor it fully, if we only partially factor it, sometimes we miss some of our solutions. But once we have it factored fully, we just inspect the factors. And quite often you can just see it by changing the sign in your head. And so here's an example of something we've done before, or pretty much done before. Now right now my equation is not solve for 0. I have nothing against the number 5, but it's not so helpful compared to the number 0. So I'm going to subtract 5 from both sides and rewrite this equation as 2x squared minus 9x minus 5 equals 0. And now when I factor the left-hand side, once I have it factored, I can see my solutions really quickly. So how do you factor this? Again, this sort of trinomial here, we were factoring lots early in the course, goes back to grade 10. I mentioned this sort of stuff a lot. It takes 2 steps at least. Usually I recommend first multiplying these together and think what multiplies to negative 10 but adds to negative 9. But then you got to either break up the middle term or you have a number of steps. And again, I've talked about factoring a lot, so honestly at this point I don't really want to bore you by just going through all those steps again. If you need to review factoring, that was some of the first lessons of the course. If you factor this properly though, you should get one of your factors is x minus 5 and one factor is 2x plus 1. Now clearly if we don't factor properly, we're going to get the wrong answers. But again, going from here to here is grade 10 math that we've been used a lot in this course and will continue to keep using. So now I inspect my individual factors. From looking at this, I can see if x equals 5, that factor will equal 0. And if that one factor equals 0, the whole left side equals 0. So that's one of my solutions. Over here, 2x plus 1 has to equal 0. So if you're not sure, just write 2x plus 1 has to equal 0. Subtract 1 from both sides. That means 2x has to equal negative 1. Divide both sides by 2. X has to equal negative 1/2. So now I can see my 2 solutions. So I'll just write it nice and officially here. X equals 5 and negative 1/2. And so solving by factoring is usually very quick and very efficient, assuming we can factor it, and assuming that the factoring side of things we are proficient with. But again, there's a reason we started with factoring in this course and had several lessons reviewing factoring. And like I said, you can go back to those videos at some point if you need a bit more review on that. So I don't want to keep repeating stuff I've done before. So what I want to do here is if I'm going to start talking about factoring again, I want to look at some stuff that we may have forgotten about or is a little bit trickier than what we saw earlier. So for example, I want to factor this. That said, the first thing you should always check for anytime you ever want to factor anything in any course is look for a greatest common factor. This has a greatest common factor of 2. So take out that greatest common factor of 2 and you have x squared minus x minus 6 left. I've now factored it partially. The question is, can I factor it more? Yes. The x squared minus x minus 6 I can factor. There are 2 numbers that multiply to 6 and add to negative 1. Those are negative 3 and positive 2. Now it's been fully factored. Now notice this question, these aren't equations here, these 3 expressions. They don't equal anything. So I can't say x equals 3 because the expression at the beginning doesn't equal anything. But I do know the expression 2x squared minus 2x minus 12 is equivalent to 2 times x minus 3 times x plus 2. And so if I adjusted this to make it equal 0, then all these would equal 0. And then my solutions would be 3 and negative 2. But that wasn't the question, so I won't do that. Okay, what about this one? This one here, you know, it's only 2 terms, but both the terms are perfect squares. It's more obvious with the first one. 3x times 3x is 9x squared. But the second term is also a perfect square. 0.8 times 0.8, or 0.8y times 0.8y does equal 0.64y squared. And you can always double check that on a calculator, but this is a difference of squares. Just not as obvious as other difference of squares. Once you notice it's a difference of squares, we should be able to factor it really quite quickly. I have 2 factors that are the same, except one's plus, one's minus. In this case, the first term will be 3x for each. The last term will be 0.8y for each. But one's minus 0.8y, one's plus 0.8y. And again, if this equaled 0, I could do more. But right now, I'm focused on just factoring some slightly more challenging examples, such as this last one. This looks kind of imposing, fair enough. If you are tempted to start distributing the 12, well, you can't do that because order of operations, we should look at our exponent first. And then if you're tempted to start expanding and simplifying this, you can do that, but I wouldn't because you're definitely going to make it more work than it has to be. So one thing I will say is if you look at the structure of this, this does have the structure of a quadratic equation in which, you know, imagine instead of x plus 2, you had just a or some other variable. In fact, let me write that down right here. Let me just say, I'll say let x plus 2 equal a. If I did that, notice what I'd have. I'd have 12a squared plus 24a plus 9. So if that looks better, which it almost certainly does, let's just ignore the x plus 2 part for a bit and focus on this, because that looks a lot simpler. So how would you factor this? The first thing I'd always check for is the greatest common factor. And the greatest common factor of these 3 terms, there is one, is 3. Take out a factor of 3, you have 4a squared plus 8a plus 3. Now, can I factor this more? Probably. Find 2 numbers that multiply to 12 and add to positive 8. If there are such numbers, we can factor it. It'll take a few steps. And again, that type of factoring goes back to, again, grade 10. It takes a few steps. But again, if you do factor that part properly, all of that should factor into 2a plus 3 and 2a plus 1. And don't forget, there's still this factor of 3 in the front. So I've now fully factored, not my original question, I've fully factored this. If it wasn't x plus 2 each time, if it was just a each time, then I'm done. I fully factored 3 times 2a plus 3 times 2a plus 1. But again, just that is really a grade 10 question. What makes it a trickier and therefore a pre-calc 11 question in terms of factoring is that this was the question I gave you. And so let's now go back to the step where I substituted x plus 2 with a, when I simplified the expression, which was a great idea. Now let's unsimplify it. Let's replace those a's with what they are, x plus 2 again. So I have 3 times 2. Actually, I'll put square brackets here. 2 times x plus 2. Because again, I said right near the beginning that let's let a equal x plus 2. Plus 3. And then 2 times again, x plus 2 plus 1. So again, it's easy to lose sight of what we're doing. I now took this and I went back. I took that a and I substituted x plus 2 back into it. And now I'm pretty much done. If I just look at this, if I distribute the 2 in each of these and collect like terms inside these square brackets, I have factored this fully. So for example, I'll have 3 times 2x, and when I distribute the 2, if I distribute the 2 to the positive 2 and collect like terms, I'll eventually get a 7. So that's another one of my factors. Same thing for the next one. Distribute the 2, collect like terms, I should get 2x plus 5. So notice, that was not a grade 10 question. And again, just factoring in itself is part of the grade 10 curriculum. We're expected to be able to work with it going forwards here. And so that was a pretty challenging question. I will say, if you did first expand and simplify this, and then distribute the 12, and distribute the 24, and then collect like terms, and then factor that, you should get the exact same answers I had down here, but it will be more work. All right, so let's get back to now solving with factoring, because here I was just factoring. So here are, again, some more challenging problems. This time I am trying to solve an equation. So let's focus on this one. So how can I solve this? Where there's that 1/4 in the front. However, that's not a big deal because I have an equation, and I can multiply or do whatever I want to both sides of this equation. And I can, if you don't like that coefficient of 1/4, fair enough. I don't really like it either. And I can get rid of it if I just multiply both sides by 4 right away. And just remember, if I'm multiplying both sides by 4, I've got to make sure I multiply everything by 4. And so 1/4 times 4 is 1. So not surprisingly, the 1/4 cancels out because that's why I multiply by 4. So I have just x squared. But I got to make sure I multiply everything by 4, or else this hasn't balanced out. So I have minus 4x minus 12 equals, on the right-hand side, 0, such a lovely number. 0 times anything, still 0. All right, so these two equations are equivalent. And the equation I've written down now is just significantly simpler. Now to solve this, let's see if we can factor it. And we most definitely can. What multiplies to negative 12 and adds to negative 0? It's negative 6. Sorry, multiplies to negative 12 and adds to negative 4, negative 6, and positive 2. So my factors are x minus 6, x plus 2. Those are my factors. So my solutions are x equals 6 and negative 2. So in the end, that 1/4 in the front wasn't a big deal. Again, I could have an equation. I can multiply both sides by any number I want. As long as I'm not multiplying both sides by 0, I can multiply both sides by any number I want. In this case, multiplying by 4 made things come together quite nicely. What about this equation on the right? Well, it's more complex, but hopefully it looks kind of familiar because it's so similar to what I was doing just a few minutes ago. In that I have an equation that is in the form of a quadratic equation, but instead of just a or x, I have x plus 3. So let's do the same thing we did before. Let's temporarily substitute x plus 3 with some other variable. I'll be boring and say a again. And so this equation now becomes negative 2a squared plus 12a plus 14 equals 0. All right, we can solve this now by factoring. And then eventually, just don't forget, the question didn't have an a in it. It had x plus 3. So focusing on this, though, if I want to solve this by factoring, the first thing I should always check for is a greatest common factor. And there is a greatest common factor of 2, or even better, in my opinion, negative 2, because then I get rid of that. I don't have that negative in the front anymore. So then I have just a squared minus 6a minus 7. And then again, chances are I can factor a squared minus 6a minus 7. And I can. And I get a plus 1, and I get a minus 7. So now I can see my solutions for a. Again, the question did not have an a in it, but I'm now done my question in terms of finding what a is. So I can see that a equals negative 1 or a equals positive 7. From looking here and here. Okay, but again, notice the question didn't have an a in it. So hopefully you can guess how to finish this off. If a equals negative 1, that means x plus 3 must equal negative 1. Well, or I guess in this case, yeah. So let's just replace that a with x plus 3. Well, that's not so hard. To solve this, subtract 3 from both sides. X must be negative 4. There's one of my solutions. So like I said, we are almost done with the a. We just, the reals are not totally done. Same idea over here. That a again, it's x plus 3. So if a equals 7, then x plus 3 must equal 7. Subtract 3 from both sides, and you get x equals 4. And so in this case, I can see altogether x equals plus or minus 4. And again, if you were to expand and simplify x plus 3 squared, and then distribute, and then collect like terms, and then factor, you should get the same answers. It would be, I think, more work, but it would be correct. All right, so lastly, let me look at a fairly standard type of problem, and that again involves trajectories. And again, I say again because we had a problem from a few lessons ago in which I was talking about the trajectory of I think it was a calculator being kicked. And in this case, it's the trajectory of someone coming out of a water slide, which again forms part of a parabola. And so the idea is when you're coming out of a water slide, the moment you escape, your trajectory forms a parabola until the moment you hit the water. The moment you hit the water, it's no longer the shape of a parabola, but during this region here, while you're in free fall, that trajectory is a parabola. And it's this model is perfect if there was no air resistance. But to be honest, in that short distance, air resistance is not having much of an effect. So that, we can model this really, really, really accurately using a quadratic function. And what I have here is a model of it, where h of d represents that trajectory I've drawn in red, where d is the horizontal distance that the distance this way, and h is the height above the pool, this distance this way. Okay, so with that said, the question is, how far, what is the horizontal distance the slider travels before dropping into the pool? How far this way will they go before they hit the water? That's what we're trying to find. So really what we're trying to do is if we imagine this kind of parabola continuing, it's probably going to look something like this. And we're trying to find where this parabola equals 0. Where the height of this parabola, or the height of height of this person above the water is 0. So once we realize we can set it up this way, I'm really trying to find where this equation equals 0. And so I can take this right here, and I can write 0 equals negative 1/6 d squared minus 1/6. Oh, that's not a 6. D plus 2. That's, in my opinion, the most important part now complete. I've understood how we can take this model of the trajectory and realize how we can use it to find, in this case, when it hits the water, which is when the height is 0. Well, there we go. Now this is extremely similar to one of the problems we did just a few minutes ago. If you don't like these denominators of 6, that's fine. Just multiply everything by 6. Just multiply both sides by 6. And so on the right-hand side, I still have 0. The left-hand side, I have negative d squared minus d plus 12. Again, I've got to multiply everything by 6. That said, while I can definitely work with this, I'd rather if these terms here, especially that d squared, rather if it had a positive in front of it, not have a negative. When I can take care of that by just going back a step, and instead of multiplying these by 6, let's multiply each by negative 6. Easy little quick change I can make, which means if I multiply everything by negative 6, this becomes a positive, this becomes a positive, 12 becomes negative. All right, this is going to come together really quite quickly now. I can factor this nicely. What multiplies to negative 12 but adds to positive 1? Positive 4 and negative 3. Which means by inspection, I can see that d equals negative 4 and positive 3. Okay, but let's think about the context of this question. What does d stand for? D is the distance this person is traveling horizontally. Well, in this case, this answer of negative 4 is not reasonable because that is actually representing this distance right here, which again makes sense in terms of the parabola, but doesn't make sense in terms of the context of this question. And so I reject that one. There's nothing algebraically wrong with the work I did, but in the context of the question, that negative answer doesn't make sense. All that does make sense is the 3, or 3 feet. I can now see this person traveled 3 feet horizontally before they hit the water. And so I'll say just this. The person travels 3 horizontal feet. Ooh, that's a messy writing. And now I'm done. So again, that answer I rejected, the negative 4, it made sense mathematically if you just look at my little sketch of a parabola, but it does not make sense in terms of the context of this question. Or another way of looking at it, this function, h of d, does not have a domain that includes negative 4. The domain is only greater than 0 to a point. And with that said, good place to stop.